Alrighty. Okay, so, hello.
Hello.
Alright, good. Alright, so now I got your attention again, and y'all ain't playing with your phone, you don't got those earbuds in, because I know y'all are paying attention. Are you covering one ear so it doesn't, like, information doesn't fall out?
Yeah.
So it goes in there and doesn't fall out the other side? Oh. Okay, let me get your full attention. Because if there's, like, music playing in the background, yes, I have, like, in my head, I actually have, like, this beat in my head. It's kind of like my walking music. Sounds like Funky Town. And so that's the rhythm that's always playing in my head. So, it is one of those things. Anyway. Okay, quite randomness. Anyway, all right, so we're maximizing area now. So we're going to maximize the area. Manufacturer makes a flexible square play yard with hinges at 4 corners. Can be open at one corner, attached at a right angle to a wall or side of a house. If each side is 3 meters in length, the open configuration doubles the available area from 9 meters squared to 18 meters squared. Is there a configuration that will more than double the play area? I don't know. So, how many sides do I have?
4.
I have 4, right? I have 4 of them, and they're all same length, aren't they? Does it mean is my screen like kind of blinking? Or am I just having a stroke?
Oh, yes,
We're all having a stroke.
No, yeah, it's blinky.
Oh, once you get as old as I am, then you kind of like worry about that. You're like, am I having a stroke? I don't know. Probably not. Anyway. Okay, so I know that by perimeter, right? My perimeter is equal to what? Right? Okay? Or another way I could actually write it would be, let me see, it would be, there's 4 of those things, right? 4 sides times x, right? 4 times x, whatever my x is. So, now, we're trying to maximize the area of this, right? So, I know that the area somewhere between this has to go either enclosed like this or somewhere else. Okay, is there any other shapes I could try and get out of this? No? How about a house? A little house? You know, like when you're like in elementary school and they say to draw a house, you get like a little generic house thingy with like a square roof, and you put like a little door on it and one window with the 2. Never mind. All right. All right. So if I'm trying to maximize the area in between these 2 things, there is only so many configurations I can go. I could actually go here too. So here's the. So could be like that. Yes? Okay. So, if I could do that, that means that this side over here is my wall. So it's going to be some value there. I could have some value there, but if I close it on all 4 sides, I know I'm going to have this. So, yeah, let's try this. So the most that this could be, so let's give it a y value. And the most that this could be is what? 6, right? Because that would be right here. That would be this one right here. That would be right there. So that would be 6 there. So it's got to be between 6 and 0. So y has to be because if it's at 0, I get a area of 9 square meters, and if it's at 6, I get an area of 18 square meters. These ones are already done for me. So I'm going to try and change this one to see what it would be. So I know that there's certain values that I'm going to have. I know that it's going to be the area of x, right? That's an x right there, right? Okay, what else do I have?
You have the length of the two tops, right?
Okay, so I can cut right there, right? And I would have a triangle on top of that. Yeah? Okay, so now. Looks like what?
Stubby pencil.
Okay. I gotta try and figure out that though. But I know it's gonna be 3, right? This is 3. This is 3, right? Just like this one over here is also 3. So I gotta try to find some value there to figure out the height of that little triangle. Yeah.
Can't you just do, split is the dash line, is that 3?
No, it's not 3. It's gonna be my y. Because I don't know what it is. It's somewhere between 6 and 0. Right? Because I'm opening this up or closing it down. So somewhere between 6 and 0. Yeah?
Wait, why do we have an X? Don't we know it's already 3?
Yeah, we already know it's at 3. But I'm just in this term so we know that it is 4x. I have 4 of these values that are 3. Okay? I'm just, as an example, knowing that. Okay, so how would I find the area of a triangle? 1/2 base times height. I don't know the height, but the base would be just y, right? Okay. So is there some ratios or something I can get out of this? So let me try it again. I'm going to insert new page, insert, come on now, page, blank. All right, so we're going back to this. So let's see, we said here. There we go. All right, and we said 3, 3, 3, 3, and this word here was my y. So closing this off right here. So I should have 2 areas here now, right? So yeah. Because we're maximizing area, I have 2 areas. I know that this is one of them, and this is the second one. But the only problem is the second one is giving me some issues. Yeah? It's giving me issues. So I know the base of the triangle has got to be y, isn't it? Base of the triangle has got to be y. And so I got to find some height out of it. So if I pull it off to the side, say, all right, I know this is 3, this is 3, this is whatever my y value is. Anyone? I could try some trig. I could do some Pythagorean Theorem, right? So I know, okay, let's try some Pythagorean Theorem off of it. Okay, I know it's going to be, because I'm only going to use half of it. Okay, because I'm going to use that as my height, my altitude of that. So if I do that,
Square root of 18.
yeah, so it's going to be y squared, right? Over 2, right? So should be, oh, I wrote it wrong. Y squared over 2. Right? Okay. Plus my height, right? My height squared is equal to 3 squared. Yeah. So, I don't like having a whole bunch of variables. So what do I want to get rid of?
Y.
Not y, because I need the y down here. I don't want the h. This is the only place I have an h, right? It's the only h I have. So let's go ahead and take a look. So it's y squared over 4 plus h squared equals 9. So h squared is equal to 9 minus y squared over 4. Yes? And I know that this should be h is equal to plus or minus square root of 9 minus y squared over 4. I think everyone's lost. Maybe? No? Now, do you see what I did there? I don't have any of the values that I need for the triangle. But I can make them up because I know I have a y value at the bottom. And I know that this right here is going to be 3. So I can use substitution for my h and plug it in with terms of y. Okay, so let's go ahead and plug that in now to a formula that I should have. So if I'm maximizing area, so my area of the bottom, A equals 3 times y, right? Okay. And plus the area of the top, so area of the triangle, area is equal to 1/2 base, which is going to be my y, times height. Ah! Got too much crap over here. And which of my h's am I going to ignore? Say the negative. Why would I ignore a negative? Can't have negative area, can't have a negative distance on this. So that's super important to understand. So now I'm going to replace it with, so go over here, h is equal to square root of okay. Okay, so let's go ahead and just plug in now. So it's going to be 1/2 y times 9 minus y squared over 4 to the 1/2. Now, does that make sense? Okay. So I think the biggest issue we had getting out of this is actually figuring out other shapes we can make with this. All right, so let's go ahead. It's going to be my d a d y in terms of y. So the derivative of this is going to equal 3. Okay, and this over here is going to be a product rule. Now it's going to be plus 1/2 quantity 9 minus y squared over 4 to the 1/2 plus, now I'm going to have a chain rule on this second one, 1/2 y, and now the chain rule, so it's going to be 1/2 9 minus y squared over 4 to the negative 1/2 times, now derivative of the inside, negative, right? Negative 1/2 y, right? Because it's going to be a 2y over 4,
Yeah.
which is going to be a negative y over 2. Okay, gotta do a little bit of cleaning up here. So dA dy is equal to 3 plus, let's do 9 minus y squared over 4, 1/2 all over 2 right there. And now over here, this is going to turn into a minus sign because all this is multiplying. So that's going to be a minus. These y's right here will cancel, but I'll still have a 2, and a 2 right here. So all those 2's is going to give me 8, right? So it's 8 on the bottom. Is there anything left on the top of the numerator? Say no. No, because this is a negative exponent, so that's going down. And I canceled out my y's. So it's going to be 1 over 8 quantity 9 minus y squared over 4 to the 1/2. Tar, you okay? You give me that crazy look again.
I don't know.
Hmm?
So much math.
Are you okay with what I did, or okay? Now from here, I get to try in common denominator, so I could actually get rid of a lot of this, right? So my common denominator is going to be 8. And then my 9 minus y squared over 4 to the 1/2, right? Okay, so I need a new page here. Insert page. So we said dA dy 3 plus
Yeah. 9.
what is there? No, it was over 2. That's what it was. All right, so 9 minus y squared over 4, 1/2 over 2 minus 1 over 8, 9 minus y squared over 4, 1/2. And then since I need that on all of them, this is over here is going to be 24 and 9 minus y squared over 4 to the 1/2. This is going to become a whole, and it's only going to need 4. So that's plus 4 quantity 9 minus y squared over 4. And it's no longer 1/2 because I completed that one. And it's minus 1. Wow.
That's a crazy one.
I know, right? There we go. And all of it is going to be over my 8, 9 minus y squared over 4 to the 1/2 equals my dA dy. All right. What can I not have? So whenever I'm doing this and trying to find critical numbers, especially critical numbers of a derivative, I have to be very, very careful about certain things. So it's not just derivatives I'm looking for. I'm also looking for undefineds. So I got to try and figure out. I'm pretty sure there's probably an undefined in there somewhere. I'm pretty sure it's going to be.
Would be just 6.
I don't know. We got to figure it out. Figure out where it equals 0. a quantity 9 minus y squared over 4 equals 0, right? Because that's going to be undefined. Okay, so divide by 8 and then square it. So it's going to be 9 minus y squared over 4 equals 0. Move that over there, so it's y squared over 4 equals, if that's negative, then that's positive 9. Okay, so right here, multiply by 4, it's 36, right? So that's going to be,
Plus or minus 6?
yep, y equals plus or minus 6.
This is y gotta be less than 6.
Hmm?
On your thing, it was saying that y gotta be less than 6.
Yeah, it's critical numbers here, right?
Oh,
Yeah, it's a critical number, so that's why it's got to be less than 6. It can't be, if it is 6, that we already had that other one, right?
So,
Yeah, it already had the one with one side. Right here, this is the one that it's 6. Yes? Okay. So, critical numbers are important, okay, especially for my applications. All right, now set it equals 0. Set it equals 0. And I can get rid of the whole denominator. Six minus y squared minus 1. I did this distribution right now. So if you could see where that goes. Okay, so from there we just got to keep going. So got to try and figure out what my y is going to be, right? I see a lot of people like eyes drooping, you know, trying not to fall asleep, but not doing too good of a job at it. Are you guys following on this, or is it, you know, I'm not feeling the love on this one. You're not feeling the love? Okay. How about
Too
this?
long.
Huh?
It's just too long.
Ugh.